Okay.
Okay. So now, I mean that what I was trying to say is that what is the condition of this filter? The filter size will be always less than the size of the image. You can see that this size of the image is 6 by 6 and the filter size is 3 by 3, right? So that is one condition. The second condition is that you can apply -1, meaning that I'm not interested this part of this. I mean that I am interested if I want to find this one 111, meaning that I'm interested those edges that matches with this angular line. You can see that this line matches with this line and this line also matches. You see it, everybody? If I draw in the filter the
Yes, sir.
111, what should I say? The straight line it will look like this angular. It will be 270-degree angular, right? So this 270-degree angular line will exactly match with this 270-degree angular line here in this picture, this line and this line. I'll show you how mathematician can identify from this matrix filter and this image how they can identify that these edges are matching together. Okay, so this is one filter. You can create any other filter. You can filter 2. Filter 2 will identify exactly this type of line or edges in the picture, right? You can see filter 2 exactly matches with this filter. Now only this one, this line does not match with another filter. Now if I ask you, can you please tell me what will be the third filter so that that filter can identify this edge? Can you please tell me what will be the third filter?
If we reverse the filter of filter 1, that
tell me it will be 3 by 3 filter. So let me draw a 3 by 3 filter. I'm just writing here. You have to tell me the values in every cell. Okay, so tell me what should I put it here?
-1,
minus 1, then
-1,
-1,
and
1,
-1.
then 1,
then -1.
1.
No,
1.
1.
1.
Okay, 1. Then tell me
-1,
-1 or 1
-1,
-1.
1,
1,
-1.
-1,
Then
1,
1 -1 -1.
-1,
-1, -1. So this will be the third filter. Okay, number 3 filter. Did you understand? So this will match with this one. Everybody, it is clear.
Yes, sir.
Yes.
Now what I'll do? Now let me show you how this convolution works. Okay, so now let us look at here. Let us consider the filter 1 first, and don't trust me, trust the mathematics, how the mathematics will work to identify these sort of edges in the image. So let us go to the mathematical formula. So what I will do first, this filter will be multiplied with this filter. Now can you please tell me, if I multiply this filter with this matrix 3 by 3 matrix, what will be the resultant matrix? What will be the result? You know matrix multiplication, right? Anybody volunteer?
1.
It will be 1, right? So I have got one answer, 1. Any other answer? Any other
3.
answer? Don't feel shy. Kamal is saying 3. Kamal, I know that you. Except Kamal and Bashir bhai, others. Okay? Others.
1 + 1 + 1 3.
Who told me 1 + 1 + 1 3? Matrix is not like addition. 1 + 1 + 1 3.
এটাকে কি যেন বলে? আচ্ছা, দুটো ম্যাট্রিক্সে গুণ করার পরে যে
Okay, so let us go to the little bit of matrix multiplication, right? Okay, let us go matrix multiplication. Okay, so Wikipedia, simple Wikipedia, right? So you can see what is happening. Can you see this example on the right hand side? Just follow my mouse pointer. Can you follow my mouse pointer?
Yes.
Yes.
You can see this is the row. We multiply row with the column. This is a dot product, right? If we make the dot product of the row with the column and add with this thing, so dot product is will be adding, right? So then if we do these things, row by column and row by column, then what will happen? Tell me what will happen. Okay.
If you add,
Yeah. So
did you
look at here.
say?
So it will be the answer is like this: matrix multiplication A1 multiplied by A2. Can you see? Plus B1 multiplied by C2. So we are computing row multiplied by column, row multiplied by column. Then what will happen? Tell me. Kamal. Another example: row multiplied by column, right? So it will be 58. Then what will
Oh,
happen?
I see.
Right?
Multiplying 1 and 2, and then multiplying that number by 3, and
Yes.
then the other line.
Yes. Look at here. 1 multiplied by 7, 9 multiplied by 2, plus 3 multiplied by 11, minus, okay, minus 4 multiplied by 8, plus 5 multiplied by 10, plus 6 multiplied by 12, right? Like this. Did you understand?
Yes.
I see now, yes.
Okay. So if I do the multiplication, it will give us the result. So if it will give us one result, okay, matrix multiplication will give us one result. So what will be that result? That result will be here, it will be 3, okay, it will be 3, okay. I'll show you. If you do the matrix multiplication, so let us do the matrix multiplication with filter 1 with that matrix, it will be dot product. If we do the dot product, it will be 3. Everybody?
Yes.
Yes.
Then what will happen? We'll move this, we call it stride 1. Why stride 1? If we move this matrix to the 1 pixel, we call it pixel in image processing. If we move this on the left hand side 1 pixel, then we call it stride 1. So if we move this 1 pixel, then it will be stride 1. Look, now it has got new matrix. Can you see? Before it was like this. Now it will be like this. Can you see it?
Yes.
Yes.
Now, once again, we multiply this filter 1 with this new matrix, and the answer will be -1, because there is a dot product, and I told you there will be minus row multiplied by column minus row multiplied by column. So if we do it, it will be -1. Did you understand?
Yes.
Yes.
Now we have got -1. Now let us move this window. Let us move this window another time like this. Okay, you'll keep moving window like this. So if we use, look at here, if we use this stride equal to 2, can you see? The previous example stride was 1. Now the stride equal to 2. Everybody, if we
Yeah.
what is the stride equal to 2? We are moving the matrix by 2 pixel, not by 1 pixel. Everybody?
Yes.
Yes. Yes.
Okay, and we will do this simple matrix multiplications. In this case, it will be -3 because there is a minus row multiplied column by minus, right? So now I think that you understood what is the meaning of this stride 1 and how we can do the convolution. Convolution is what? Convolution is that we will do filter 1 for the case of stride 1. We do the multiplication, we get the result, then we move this window, then we get another value, we move the window, we get another value, we move the window, we will get another value. Now, can you please tell me now what will happen after this point? What will happen?
Would you move down?
We'll go down. Okay, we'll go down by what? By 1 pixel. Okay, look at here, we are going down by 1 pixel. Can you see it? Okay, then we'll
Down
do
and to
again
the
the
left.
same thing. Yeah, we will do the same thing. So if I keep continue doing these things, so this will be our resultant values. Now, can you see that my original image was 6 by 6? Can you see?
Yes.
Now the new image will become what? The new image will be 4 by 4. Can you see it? Why it is 4 by 4? Why not 6 by 6?
Because there's zeros.
Not because of the zeros, because we are multiplying 3 by 3 matrix and we will get one value in the both side. These values, these columns and these rows are omitted because these values are not coming. The other values are coming automatically because it is a 3 by 3, and the 3 by 3 is reducing by 1, and that is why it's giving me 4 by 4 values. And another thing is the stride equal to 1. Okay, due to the stride equal to 1, meaning that these two, one row and one column will be deleted. So if we just deleted 6 equal to 6 minus 2, because one row, one column 2. So 6 minus 2, it will be 4, and 6 minus 2, it will be 4. My question is that if this stride equal to 2, what will be the size of this matrix? If stride
Would it
equal to
be
2, sorry,
5 into 5.
3?
it
3
will
by
be
3?
it will be 3 by 3.
3 by 3?
I think it will be 2 by 2, right?
2 by 2?
It will be 2 by 2. Okay.
Okay.
3 by 3.
Sorry, say it again.
50.
Okay, I did not hear you. Okay, now let us come to the point. Now, how we can identify the edges? How we can identify the edges using the convolution? Everybody, look at here. Look, this value is 3. So let me identify the maximum value. This is the 3. And what is the 3? This is the 3. Can you see? These are the two values are maximum. Can you see it?
Yes.
Yes.
So from where we got the 3 value? This 3 is coming from multiplying by this matrix, right? This one, isn't it?
Yes.
Yes.
And this 3 is coming from multiplying by this matrix in the original image, right?
Yes.
So if we go there, this matrix and this matrix, our computer can go back there, and our computer can say that in this matrix and in this matrix, these edges is appearing. These edges are appearing. Did you understand?
Yes.
Okay.
Yeah.
So mathematically, we have proved that mathematically we can easily identify where exactly this edge is appearing in the image. Okay. So it will be like this. You can see it will be like this. Can you see? This maximum matrix is coming from here. Can you see it? Understand it?
Yes.
Okay. Now let us go to the filter 2. Okay, repeat this process again, and you can see if we use the filter 2, filter 2 will give us this. You can see only these 3. Can you see? This is the maximum. Okay, and this is coming from this matrix. So I mean that using the filter 2, we can identify this edge. Now using the filter 3, you can easily identify this edge. Did you understand, everybody?
Yes.
Yes.
Okay, so if that is the case, in today's class, I will not do anything. You will do these things. You have to work with me. Okay, everybody, please open up your Google Colab, or everybody, including Adib and Ibrahim, Khalilul and Azim. Okay, everybody open the Google Colab. Let us do practice today. Okay, with me. Okay, are you ready to work with me, or you want to work at home? Tell me.
Yeah. How do we join the lab?
Can you please tell your name so that I can refer to you? Samuel, right?
Yes.
Okay, Samuel, that's a nice question. I'm sorry that I could not explain it clearly. You have got the Gmail account?
Yes.
Okay, just in the Google, write down Google Colab. Write down Google Colab. Follow me, okay?
Yes.
Google Colab. Okay, then enter, and then you just click on the Google notebook, Colab notebook. Okay, this one,
Okay.
and it will ask for your username and password, your Gmail account and password. And by doing these things, you can easily join into the Google Colab, and you'll be able to see a screen like this, Okay, just forget about the code. Code is my code, but it will look like this. Okay, this window. Everybody, especially Samuel. Okay. So now you can follow me Okay, I will send you all this code in the chat right now, because we don't have sufficient time to write down the code. You just copy and paste in your computer. Okay, and then I will explain line by line what I'm doing here. Copy and paste in your Google Colab. Oh, Google Colab. No, that's another problem. Google Colab. You cannot open this Rubik's PNG file. That is another problem. Okay, those who have got the Python installed in your computer. Have anybody has got Python installed in your computer? Especially those who are from Bangladesh.
Yep.
Bidhan,
Yep.
you have got Python installed in your computer?
Yes, sir.
So open your Python, okay? Python Jupyter Notebook. Don't open the Google Colab. Google Colab. Let me check Google Colab. What data is there? Image data is there. Google Colab. Let us go to SKMS. SK image data for edge detection. Let me SKMS. Oh, there is a camera. Okay, so there is another. Okay, you can use that one. So those who are using the Google Colab, I will give you another code. But those who are not using Google Colab, use my code. And those who are using the Google Colab, just hang on. I will give you the code for the Google Colab, because in Google Colab you cannot load the data from your local computer. It is a really difficult task. Okay, everybody. Now I'm giving you this code. What you have to do is that you have to write down the path name. You have to write down the path name and the image name. So I'm going to give you the image file, that the image that I'm using in my example. Okay, you have to do with me so that you can understand better. So Rubik's.png image, where it is there, where it is. Multimedia design. Rubik's image. Rubik's image. ABCD. Rubik's image. Yeah, this one. Download this file to your computer. Okay, everybody.
Okay.
Okay, download it. Then what we have to do is I will stop sharing my screen. Okay, and anybody, could you please share your screen? Okay, those who are using the Python code. Okay, those who are using the Google Colab, just hang on. I will give you the code. You can do it at later stage. Just open the Google Colab. But those who has got the Python program installed in your computer, anybody can share their screen. Anybody? Adib, you want to share your screen? Adib.
Professor, I'm using the Google Colab.
Oh, you're using the Google Colab. Any other person who will share the screen?
I am using VS Code.
You're using GS Code?
VS Code, Visual Studio Code.
VS Code, VS Code. No, I'm looking for somebody who is using Jupyter Notebook. Anybody using Jupyter Notebook?
Jupyter Notebook, but in VS Code.
Okay, VS Code. I don't want to introduce VS Code to others. Okay, there will be another IDE. Kamal, you have got the Jupyter Notebook installed in your computer?
No, I could try and share my screen.
No, I don't have.
Okay, yeah, share your screen, please. Is that Samuel?
Yeah.
But you are using the Google Colab, right?
No, I downloaded the file.
Just share the screen. I want to see. Share the screen.
Okay. Can you
Oh,
see
no,
it?
not this one, not this one. I'm interested to go for the Jupyter notebook. Can you please stop sharing screen then? Stop sharing the screen. Okay. So now what I'll do, Yuan, share your screen. Yuan, are you there? No, Yuan is not there. Shafil, share your screen.
Okay, sir.
Mustafa, are you there? Mustafa? No. Okay, so okay, Shafil knows little bit about the image processing. That is why he has opened the image. So follow Shafil. Okay, today I will not do anything. Follow Shafil, everybody. Okay. So what you have to do, just write down J equal to IO dot IM read, right? Shafil, don't move that much, okay? Because it is blurring. Then what will you have to do? You have to write down. I think that you downloaded the rubiks.png file, right? Everybody?
Yeah.
Then what you have to do, wherever you have stored the data, you need to give the path name. You know, path name meaning URL, the path name of the file. Then you have to write down rubiks.png within the single quotation. Just try to, this is the that is how we can open an image in the computer. So open the image in the computer, and then you can say that io.im show, it will show the image. I want everybody to do these things so that they can see the images. If you have done it correctly, please say yes. Adib, you have done something.
But could you please show us again the downloading of Rubik's?
Okay, I have already
Is it
given in
just
the
from
chat.
Google?
No, from the chat. Just look at the chat. I have already uploaded the file. Okay, go to the chat in the Zoom. In the Zoom, there is a
Oh.
chat. Okay, can you see in the chat?
Okay, thank you.
Where I have the code, I have given you the file rubiks.png. If you did not get it, I'm uploading it again. Okay,
Yeah.
got it?
Yes.
You have got it, right?
Yes.
Okay, so I think that if you do these things, you can see the Rubik's picture, right? Everybody? Now, those who are using the Google Colab, Adib, can you please help me? What file they can do, they can use in the Google Colab?
Professor, should I share my screen?
Yeah, sure.
Okay.
Shafil, stop sharing your screen. Yeah.
Can you see my screen?
Yes.
So what I did, I downloaded the picture you attached with the, chat, and I just uploaded in the content thing, if you can see my left. So say it's something like that, and then you have to run this first part of the code, and then you can go to the file section, go to the content, and you can upload the file. It will show your Rubik's file here. If you have already downloaded, so you can just upload it and it will be here. And so in the code, it right now it is something like
You don't need to write down the path name, right? Because it is in the
yeah, it is already in the folder. So I just wrote the name of the picture and it will show picture.
everybody, have you done it? I want you to do it now. Okay, this is very important to learn the deep learning. How does it work? Okay, let me ask Rafi.
I can't install the SK image.
Oh, you have to install. No, in the Google Colab, you don't have to install anything. It is already installed. Google Colab. Bidhan Roy. Bidhan. Looks like Bidhan. Okay.
Yes, I've done it, but I've logged into Zoom with my phone, so I can show. My laptop was acting slow.
Okay, so it is working, right?
Yeah.
Ronnie, Samuel, did you do it? Samuel? No. Okay, fine.
I don't know how to join the collab.
Okay, so join the collab and follow the same way that Adib has suggested. Okay. Now, Adib,
Yes, sir.
just follow the Adib's code. So what Adib have done? Adib has opened the rubric.png. I will discuss about the library in the later part. What are these doing? Okay. So what is happening? J is a variable. I'm reading the image file and storing the data in the J file using the image read. In short, we call it IM read. Okay, using the image read, I'm just reading the file and storing the data in the J file. And if I saw image show, IM show of J, it will show the images, right? So Adib, go down.
Yes.
Go down. Okay, so that is the thing. Now remember that we are interested to learn how does the convolution works in reality. So what I'll do, just write down this code. Write down this code. Follow. You don't have to write down anything. Just follow my chat window and write down this code. This one, Adib. Copy and paste from the chat. Everybody, those who are working with me, just copy from the chat and paste it. It will work. Okay, it is working, right? So it is done. Okay, so it is done. Now, what I'm doing, this is a color image. Color image meaning red, green, and blue image. So I'm converting this red, green, and blue image to the gray image because I will do the convolution in a simple way. That is why you can do the convolution in the red image, green image, and blue image, but I will do the convolution in only gray image. That is why I'm converting this RGB to gray image. Okay, so J is my image file. I'm converting to the gray image. Now let me show you how does it look like. Adib, can you show this io.im show? I want to see that how does it look like. I've converted this image to the gray image. Now I want to see, does it look like a gray image or does it look like a color image? Can you see it is a gray image? Can you see it?
Yes.
So we have converted a color image to the gray image using some programming language. Okay, using some traditional image processing techniques. Okay, now remember that this is very old technique, 50 years old technique. Okay, now what I'll do, I will convert this image to a array. We need to convert this image to array because we will do some mathematical operation. To do the mathematical operation, we need to convert this image to a number. So, copy this chat from the Adit, copy this one and paste it. Kamal, did you understand what I'm saying?
Yeah, it ran.
Lastly, I missed something.
Which one? Tell me.
Especially, I was working to find the upload the image in Colab. At that time, you are working, so I lost many things.
Okay, so I'll give some time to others to, I'll just repeat some of the things. So yeah, I'm giving you time. Please say yes. Kamal, please say yes once you have done. Okay.
Okay.
Yeah. Shafil, are you doing?
Yes, sir.
Shanta, you have got the Python installed in your computer, right? Shanta?
Yes, sir. Yes, sir.
So are you working with us or you are just looking, just watching?
স্যার আজকে আমি যাব তো ক্যাম্পাসে যাব তো স্যার
Oh, আচ্ছা
কম্পিউটার থেকে নেই ফোন থেকে আসি স্যার
আচ্ছা Dolan, have you got installed Python in your computer or not?
Yes, sir.
It is working in your computer?
Yes, sir.
Oh, nice. Rakibul.
Yes, sir.
Are you working with us or just watching?
Today I'm watching
Okay, fine.
from my phone.
Okay. Bidhan. No. Romy.
Sir, I'm watching.
Okay.
I'm working in Google Colab.
Is it working, Rafiul?
Yep.
Mine. Oh. Is it working?
Yep, it's working.
Okay. And meme. Is it working in your computer? Kamal done? Kamal?
No, I cannot upload the image in Colab, Google Colab.
Okay. Can you share the screen? Maybe Ajib can help you.
Should I stop share, Professor?
Yes, please. I want to see the Kamal's window. Kamal, please go ahead.
Yeah.
Share the screen.
Okay, I have given the share.
Okay. So Adib, can you help? Because this collab, go to the sample data, click on the sample data. First, you have to go for the
Professor,
right?
I think the
Yeah,
professor
Rubik's image.
needs to open a new file.
Notebook.
I mean, new notebook. Yeah.
File. Go to the file. Kamal, go to the file.
Yeah, Rubik's. This file is.
No.
Yeah.
Go to the file menu. Yeah, file. Click on the file. No.
Okay.
Up. Yeah. After before the beside the edit.
Okay.
New notebook.
I see. New notebook.
Okay, Samuel, follow Kamal. Samuel, are you there? Okay. Now go to the folder.
Yeah, it comes.
Samuel?
Yeah. So you can click the file figure at the bottom of that thing.
Bottom?
At the left column. Yeah, this one. So now
Samuel.
if you run the code, yeah, you have to upload the picture here in the sample data.
I see. Upload while calculating. Okay.
So I think it uploaded inside. Okay. It's also okay. Yeah.
Yeah.
So
Then
just
copy from the chat and paste it here. Okay.
What to do? Copy.
No, not this one. Copy the code from the chat. From the chat, Zoom. Go to the Zoom. There is a chat in the. Yeah. Go to the chat. Where is the chat? Right. You cannot go to the chat window.
Yeah, I cannot because I am sharing probably. This is the problem. Maybe.
No, you can.
Oh, yeah.
Yeah, you can.
Okay.
Okay.
This good?
I cannot see anything. Copy and paste. Okay, you're sharing this window maybe. Yeah, copy and paste here.
Yeah, RGB to gray and
Yeah,
NP.
yeah. Before that, there is 3 or 4 lines of code.
Yes.
Okay.
Oh, shit.
Yeah. I'm sending you again. Okay.
Okay.
Yeah. Mahbuba, can you hear me?
Why to paste? Is it in code or text?
No, here. Where is the cursor is blinking? Yeah. Then run.
Okay.
Play. You know, there is a play button. Beside that code. Yeah, play. It will work.
Okay.
Then
Very
again,
good.
you can even click on the plus code. Click on the plus code.
Okay, I'll do, but the remaining part. Oh, only
Okay.
this.
No, not text. Right. Click on the plus. Okay. Yeah. Then write down the another code from the chat. Okay. Copy and paste, and it will work. Okay. Now you can stop sharing. You can copy and paste. It will be very easy. Okay. Adib, share this screen. Adib.
Yes.
Mahabubun Nahar, right? The PhD student Mahabubun Nahar.
Yes, sir. Yes, sir.
Mahabubun Nahar, did you run Weka in your the paper that we are sharing?
No, sir. I'm just watching your from my mobile.
No, I'm asking you the paper, the Kamal, the paper with the Kamal.
Oh, I'm implementing Weka.
No, no,
using
no,
Weka.
no, no.
That's implementing, not complete. Implementing.
Okay, nice, good. So can you please stop sharing the screen, Kamal? I want to go to the Adib because you can do these things, okay?
Okay, thank you. I
Yeah.
am doing.
Yeah. Now you can do it, okay? The rest of the part will be very easy.
Okay.
Now, Kamal, Adib is sharing the screen. So you have converted this, the gray color. Once it is, remember that we are trying to introduce the convolution. Then we have converted this into the array. Did you convert to the array?
Yes, Professor.
Okay, so if we have converted to the array, now let us copy and paste.
Sorry,
this one.
Partho.
Yes,
But I have not imported the image here as well in the code.
Follow the same code that
I think, Professor, you have imported your image inside the sample data. So what would be the easiest way? I think just right click on the rubiks.png and copy path, and then just paste that path here. So for me, it's rubiks.png, but for you, it may be different. So just paste the path there. It will be the same.
Done, Kamal? Okay, I'm just taking some time. Don't be impatient, because at the last you will see some good thing. Okay, just wait.
But I think carry on. I will try later. It's not. Yes.
It will work. It is working, right?
Okay. But how to import this image in MATLAB code?
How to show? I mean, you have to write this line of code. io.info j.
In chat window?
Professor, you can just copy this line.
Yeah, you can copy it in
Imread.
chat.
Okay. Imread Rubix. Okay, thank you.
Is it working?
J equal to.
So you have to change this part to your path where you have uploaded the picture.
Yeah.
Mahabubun. Yeah, is it working, right, Kamal?
No, just I have imported the image, and then in a variable j.
Yeah, then you can see if it is working. There is no error, meaning it is working. Okay.
io.info, is it?
Yeah, and inside the bracket, give
Yeah,
the
the
parameter.
variable.
Okay. Yeah,
Understand.
it will show the image.
Yeah, it's
I
working
think
now.
Yeah, it is working, right?
Okay, thank you.
Okay, so if it is working, the rest of the part you can follow us. So Adib, just use this kernel that I have put in the chat. Everybody who is working with us, just copy and paste this line in your computer.
But
in the chat.
but you have changed the color into grayscale.
Yeah, that we have used some another code, j equal to another code. Follow the chat, you will find.
Okay.
Copy and paste. Copy and paste. Okay. Okay, so Adib, copy and paste this one, and follow Adib. Everybody follow Adib. Okay. So I will explain this one. This is the kernel. Can you see? This is the kernel. This is called Laplacian kernel. This kernel is called Laplacian kernel. Okay, because this kernel was implemented using the Laplace equation. Everybody, this kernel is very popular kernel, universal kernel. This kernel is used to detect the edge automatically from the image, any type of edge from the image. Okay, everybody.
but I
Wait, wait.
didn't get any numpy array.
Numpy
Who
array.
is asking? Who is asking? Who?
Rafi.
Rafi, because you did not import the numpy. You import the numpy array. I think that we have imported. Did you import numpy as np?
Yes, I imported, but
Yeah.
after running the code of here number 6,
Yeah.
I didn't get the output as a matrix.
Okay, show me. Adib, can you please share, stop sharing this
Yeah,
screen?
yeah.
Rafiul, show me.
Okay. Can you see?
Yeah. Okay, it is working. So what is wrong? Go down. J equal to np dot array. Yeah, it is working. Go to the next line.
I didn't get any output here.
No output is here. It is converting this data into an array data, numpy array data. Okay.
Oh,
Try to check. Write down type type. Write down type type. Inside the bracket, write down j.
J.
Yeah. Enter. Run it. Run it. You can see it is a numpy array. So it has been converted to numpy array. Did you understand?
Yes.
Okay. Stop sharing this screen. Let us go to the Adib. Okay. Adib. Yeah, share this screen. So today I will not do anything. You will follow some others work. Okay. I'll just explain. So what is happening here? We are using a universal kernel that is -1 8. So this kernel is called Laplacian kernel. Somebody did PhD to generate this kernel only. Okay. Now what I did, k equal to convolve j with s. So what is the convolve? This convolve is the convolution, meaning the thing that I have shown in the PowerPoint slide. This is the convolving j with this kernel. The name of the kernel is edge, or name of the filter is edge. So it will convolve j with the edge, and mode is constant, meaning it will not change anything to the kernel. Okay, it will not change anything to the kernel. Mode can be any other things, but you can consider the mode is constant. But the most important part is that it will create a convolution with j and edge. And you know what is the convolution? Did you understand? Anybody? Okay, if you say yes, yeah, if you say yes, I feel confident. So the resultant image is k. Resultant image after convolution, the resultant image will be k. So Adib, go down. I will show you. I will give you another line of code. Just copy and paste.
Yes.
Okay. I will give you another line of code and copy and paste. Okay, and see what is happening. Can you see? It has identified the edges of this cube image.
Yes.
Everybody, those who are implementing this code with us, can you please say yes?
Yes,
Anybody?
sir. Yeah.
It is working. It is working, right?
Yes, sir. It's working.
Yes, it's working.
So Adib, go up a little bit.
Yes.
So look, we are using this filter -1 -1 -1 -1 8 -1 -1 -1 -1. This is called Laplacian filter. Okay.
Yes.
Now you can use some other filter. Go down, Adib, go down.
Yes.
So let us create another filter. Shafil, is it working in your computer? Shafil?
Yes, sir. It's working.
Good. So now let us create another filter. Okay. This filter is called sharpen, meaning it will sharpen the image. Okay. So using the convolution, you can sharpen the image, you can detect the edges, and you can do many other things. I will tell you. Now, copy and paste this code to your computer, Adib.
Yes, boss.
From the chat. So this is another filter, sharpen. You can see the filter is 0 -1 0 -1 5 -1 0 -1 0. It's a 3x3 filter. Okay, and we have created another k. So now show the after the convolution, show the image, and you will see how does it work. Okay, Samuel, is it working in your computer? Samuel,
Yes.
Samuel, is it working in your computer?
No.
share your screen. We want to help you. Share your screen. Samuel, share your screen, please. Okay, so go to the Google Colab. Go to the Google. Close it. Close it. Close this window. This window is not required. Okay, close it. Yeah, I'm just helping you. Go to the file. Go to the file on the left top. Yeah, click new notebook. Click new notebook. Okay, go to the folder. Just go on the left on the leftmost column. Yeah, go to the yeah, go down, go click on the folder. Yeah, then yeah, click on the sample data, and then right click on the sample data. Right click on the sample data. Right click, then upload. Click upload. Why did you download the file? Why did you download this image file? Where? In which location? Go to the download. Go to the downloads. Yeah. So the name of the file is Rubik's, right? Did you download it in the download or desktop? I cannot see. You can use any image. You can use any image. I can see lots of images you have downloaded. You can use any image. Have you got any image in your computer? Any agricultural image? Yeah. You go for a bread and oven, that image. Okay. Yeah. Open it. Open. Okay. Now, copy and paste from the chat. I'll give you the chat. This one, just copy and paste. I'm giving you this. No, don't copy right now. I'll just copy right now. Yeah, copy and paste this one. Rafi is saying, is it CNN? Yes, we are learning CNN. This CNN, I mean that I will explain you how does the CNN work. Okay. Samuel, did you copy and paste? Samuel?
Yeah, this whole thing, which
Yeah. Samuel,
from SKM.
Yes. Just share the screen. Share the screen. Okay. Share the screen. Yeah, copy and paste over there. Yeah, just add code and write down. Yeah, paste. Control V. Oh, you did not copy that one? First, copy that one from the chat. Copy that one from the chat. No, from not here. You're printing. Cancel. From the chat, go to the chat, Zoom chat. Go to Zoom chat. I cannot see that one, Zoom chat, and copy the last message that I have sent you. I'm sending only you, okay? Not everyone. I'm sending only you. Copy and paste that one. Did you copy and paste? Paste it. Paste, Control V. Over there, just, yeah, Control V. Yeah, then run it. Run, play. On the left corner, this play button. Click on the play button. Yes. Now it is working. Now write down J equal to. Now I am showing you J equal to. Next line. Yeah. Just write down J equal to IO. Not two. Delete the two. Yeah. IO dot IM READ. Yeah, put round bracket. We call it first bracket or round bracket. I don't know, what do you call? If I can help. Yeah, just click that one. It will work. No, just press the round. Okay, so parenthesis. Yeah, I am right. Round parenthesis. Okay. After I am read. No.
Give the first bracket after I am read. Give the first bracket.
Do what now?
READ. You have
READ.
AD, yeah.
And then press play.
No. Then press Shift 9 in your keyboard. Press
Shift 9.
in your keyboard. Shift 9.
Okay.
Then in your keyboard, press this single quotation. Single quotation.
Quotation.
Yeah, not double quotation. Single quotation.
I don't know why it auto corrects to that.
Yeah, it should be single quotation
How do I fix that?
from the keyboard. Just don't press Shift. Just press Shift. Double quotation. It will come. Yeah.
Like that?
Then
Oh, okay. Gotcha.
okay, then go to the sample data. Go to the sample data. Go to your pointer sample data. Move your pointer to the sample data on the left.
Yeah.
Right click. Then copy path. Right? Copy path. Yeah. Then go to the code in between the single quotation. Click on the single quotation.
The single, where is it?
On the code that you have written single quotation.
Hmm.
Sir, I think he needs to copy the path of the image.
He
Okay.
didn't upload the image.
Yeah. Oh, did you not upload the image?
Fire
Maybe
cooked
Samuel.
bread, right?
Samuel, what I can do? Give me access to me. I'll show you. Give me access. Accept it. Okay.
Okay.
Did you give me access? Yeah. So. Oh,
So sir, it's in content.
content, right?
Yeah.
Okay, upload, right? And let us go to the bread in oven, right? Okay, done. Oh, this is AVI file. AVI file will not work. AVI file is a Photoshop file. Okay, so upload any other file. AVI file will not work. I want to go for AGIF, any JPG file.
How about the mushrooms that can eat plastic?
That is the JPG file, PNG file. Okay. Yeah. Don't move your mouse. I'll do it. Okay.
Okay.
So done. So it is done. Mushroom and oh, this is very long name. So how I can make it? Okay, copy path. Then follow me. Huh?
Okay.
My keyboard is not working in your computer. Paste. Where is the paste? Can you see any paste?
There's no paste. I was
Okay.
doing Control V.
Control V. Put Control V. Yeah. Press Control V. Okay, so it's also AVI file. Okay, so now not a problem. So it will do content mushroom. Let me rename this file. Very long name. I don't want to type that one. Rename the file image. Okay.
Sure.
Image.png. So in the content, write down image.png. Right.
Okay.
Right. Done. So now let us go to the another code. Now let us write down io.image show j. It is showing the image, right? It is showing the image. Can you see?
Yes, that's great.
Okay, so can you stop sharing the screen? And
Okay.
now you can copy and paste from everything from the chat. Keep it with you, and you can play with it. Okay,
Okay.
Samuel. If you face
Yeah.
any difficulties, I will in a WhatsApp group. You can ask me any question anytime. Adib, share your screen.
Sir, can I share my screen?
Rafiul, who? Yeah, share.
No,
your screen.
Bidan.
Bidan, share your screen. Yeah. Please go ahead. Bidan, go ahead. Yeah. So what is the problem? It is okay,
Is
right?
it okay or not? I want
It's okay.
to.
Yeah, it is okay.
Thank you.
Okay. Yeah, you can stop sharing the screen. Let us go to Adib. Adib, share this
Yes.
screen.
You can see my screen, right?
Yeah, Bidhan, can you stop sharing your screen? I want to see the Adib's screen. Yeah, Adib.
Yes,
So we can see Adib's screen. Okay, fine. So now what we have done, if you follow my chat, I have used another kernel. Adib, go up little bit.
Yeah.
Look, here I'm using another kernel, 0 minus 1, 0. So I have changed the filter a little bit. And because I have changed the filter a little bit, look, this image is, is little bit sharp now. If you go to the down, this image is looking little bit of sharp. Can you see?
Sir, sorry for interrupt. Sir, in sharpen kernel, I got some error.
Share your screen. Adib, stop sharing the screen. Yeah, share your screen. Okay. So let us go here. Just okay. Wait. Go up. Go up. Sharpen equal to np.array. Just let us look at here. What is the error it is showing? Just go to the red color here. Okay, red color here.
Yes, yes.
It shows the image. Okay, it shows the no, that one, the 0 second, before the 0 second, there is an exclamation mark in red color. I want to see why it's a red color mark. Click on here, click on there.
Maybe she's not running the NumPy code.
Go up, go up, go up, go up, go up. No, NP is working.
Yes, sir.
NP is working. So sharpen equal to, maybe you have put some space here, because in Python, space has got the problem. Before the sharpen, is there any space?
No, sir. There is
No
no space.
Okay.
Sir, I just copy your code and paste here.
Yeah. Just delete some spaces somewhere else. I don't know why it is not showing. Just delete the delete the K and everything. Delete this convol. Oh, convol. Just go up. Convol. Go up.
Yes.
I think that you did not include the convol. Go up.
Oh.
Go up. Maybe you have missed one. Go up. Convol is working here. Constant.
Yes, sir. Working here.
Yeah. Go down.
11 line.
Yeah. Go down. I don't know why it is not working. It should work. Constant. Let me check. Filter weights array has incorrect shape. Okay. So this shape of this go up.
Yes.
It is J. Go up. Go up. Go up. Go up. Go up. No, go down. Go down. 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 So problem is some spaces here. Okay. Sharpen.
Yeah.
Just delete this last line and try to find the shape. Maybe we can resolve this issue once we finish it. Okay. Dolan?
Okay, okay, sir. Okay, okay. Thank you, sir.
Because because it is already late night.
Yes, yes, sir.
Especially, I'll be with you once we finish. And those who are from Bangladesh, I'll be with all of
Yes,
you.
sir.
Okay.
Okay, okay, sir.
Stop sharing the screen.
Yes, yes.
Adib, please. Adib.
Yes.
Yeah. Okay, so this is the thing. Now from this one, I will give you another example. Let us see whether I have got another example of kernel is not, or whether I have got another kernel. Yeah, I don't have any kernel. So from this example, what we can tell? What we can tell? Adib, can you show the sharpened image and can you go up the edge image? So from these two examples, what we can tell? We can tell that if we change the filter, if we change the filter, okay, the image processing or the detection of the edges or detection of the features of the image will be different. Am I right or wrong?
Right.
Right.
Okay. If we change the kernel, then the feature from the image that we will receive will be different. Did you understand?
Yes.
Now I will show you another thing. This idea of changing the kernel is very difficult. Okay, in the past it was very difficult. What will be the suitable kernel? Nobody knew that this is the suitable kernel, and many people have done their PhD just designing a kernel which kernel is suitable for an image. Did you understand? But the new technique that was invented by Professor Hinton in 2006, that is called, not 2006, 2012, that is called convolutional neural network. In short, we call it CNN. This is the hotcake area in these days, okay? We call it convolutional neural network. This convolutional neural network, if you use the convolutional neural network, you don't have to worry which kernel is suitable for your problem. The convolutional neural network will automatically generate a number of kernels, even hundreds of kernels, different kernels, and it will automatically identify which kernels are good to identify the edges, to identify the features from your given images. Do you understand my wordings?
Yes.
Yes.
Samuel, are you there? Samuel,
Yes.
did you understand my wordings?
Yes, I can understand.
Okay, so what I'm trying to say again, that it is a challenging task to identify the suitable kernel for an image that will solve our purpose. CNN, or convolutional neural network, helps us to identify the suitable kernels. Okay, and this kernel will satisfy our demand or our aim or our goal. Okay, that is why I wanted to show you the purpose of the kernel and how does it work. Now in the CNN, another thing that works is called pooling. Okay, so now I will show you another term called pooling. Okay, so what is a pooling? I'll show you right now. Pooling is used.
So should I stop my sharing?
No. You will do everything and others will follow you. Okay, I will not do anything now today. So Adib, can you copy and paste this line to your computer?
I'm not seeing any line, so I think.
Oh, I have just copied it to the Samuel only. Sorry. Now can you see it?
Yes, please.
Yeah, copy and paste. Everybody, those who are working with us, copy and paste. Yuan, are you working with us? Yuan? I think Yuan is sleeping. Yuan, are you there? Okay. So run it.
Yeah, I've already ran.
Okay, so what are we doing? We are doing the pooling. Okay, pooling is, what is pooling? I will show you in short time. So then if I do the pooling, then what will happen after the pooling? Show the image again.
Yeah,
I'm just copying and pasting the code. You can show it. Okay, show the image of the pooling. JMax, not K. JMax.
Yeah. JMX.
Yeah, run it. Look, can you find any difference between this picture and the original picture? Go down. Adib, go down and plot the original picture. Plot. I am sure J, CMAP gray. Okay. Plot original picture. Original picture is J.
The background is removed here.
Come down. Yeah. No, background has not been removed. Just replace K with J. Run it. This is the original picture. Do you find any difference between these two pictures? There is huge difference between these two pictures. Anybody?
In second
Adib.
picture,
Yes. Adib, can
in
you
second picture, we show the line is so dark.
No, that is not the right thing. Adib, can you please little bit make so that we can see these two pictures all together? Control minus.
It's like the original picture is a bit sharper.
Control minus.
Yes.
Adib, just press control. Press control minus.
Not actually working.
Control minus. Press control and minus. Yeah.
Is it the pixels?
Who is saying? Who?
Samuel.
Yes, that is right. You can see the difference between the two images. This image is shorter. This image size is 100 by something, 100. But the actual image is 300 by 300. Can you see it?
Yes.
Everybody, do you agree with me or not?
Yeah, I can see it now.
So the pooling, if you do the pooling without sacrificing the quality of the image, you can compress the image. That is called pooling. Okay. There are different types of pooling available. One pooling is max pooling, another pooling is mode pooling. Different types of pooling are available. Okay. So here I have used the max pooling. Now you might ask me, what is the max pooling? Adib, can you please stop sharing your screen? Then I'll explain you what is the max pooling. Bashir Bhai, can you understand these things? Today I am just trying to explain the convolutional neural net in different ways. Bashir Bhai?
Yeah. Thank you. Yeah.
Don't get impatient, please. I'm going step by step. Every step is very important to understand convolutional neural network. Okay, so I'm explaining you. Yes.
What is pooling?
I'm explaining you pooling right now. Okay. I'm just explaining pooling right now. Let me check my PowerPoint slide. I have got many PowerPoint slides. I need to find the pooling. Yeah, this one. I got it. So I'm sharing my screen. Okay. Sharing my screen. Can you see it?
Yes.
Now, this is a max pooling. What is happening? If we do the filter 1 or filter 2, we get these values, okay? If we do the filter 1, in the previous example, do you remember in the previous example, we did the filtering and we got this value 3 and 3. Can you see?
Yes, sir.
And if we use the filter 2, this filter 2 is this one, and this filter is this one. If you use the filter 2, we get this 3 value, right?
Yeah.
Now, what we will do, we will do the max pooling. Once we have got these things, so let me delete my wording. So let me do this again. Now, look at here. If you do this filtering to our original image, we get this resultant value. Now, in this resultant value, in this convolutional neural network, we do the max pooling. Now, the question is, what is the max pooling? The max pooling is, we try to find, we just decide that where we will apply the max pooling, where, in which location we will apply the max pooling. How we can decide? We will say, okay, they take the max pooling in the 2 by 2 matrix. Did you understand? Here I'm considering the max pooling in the 2 by 2 matrix. It is your option. You are the user. You can choose how you will do the max pooling, in which location. Will you go for 3 by 3 matrix? Will you go by 2 by 2 matrix? Will you go by 1 by 1 matrix? Right? Everybody, 1 by 1 matrix, it will not do anything. You have to go for at least 2 by 2 matrix. Now, here this example, I'm using the max pooling for 2 by 2 matrix. In this 2 by 2 matrix, what I'll do, in this 2 by 2 matrix, let us go to this one. I'm just showing you, just follow my pen drawing. Okay, in this matrix, how many values are there?
4.
4 values are there. What is the maximum value out of this 4 value?
3.
3, right? So we will delete the other values. We will consider only 3. Do you understand?
Yep.
Everybody?
Yes, sir.
Now let us go to the second matrix. Which one is the maximum?
0.
Okay. Which one is the maximum? What will be the third one?
3.
3.
What will be the fourth one?
1.
Right? Same thing with the others. Okay. Then look, before the image size was 4 by 4, right? Right? It was 4 by 4, right? After doing the convolution, we have got the reduced size of the image, 4 by 4. From the 6 by 6, we have got the 4 by 4. Now, out of this 4 by 4, if I do the max pooling, what will be the resultant size of the image?
2 by 2.
2 by 2. What will be the resultant size of the image? 2 by 2. Did you understand?
Yes.
Yes, sir.
So what is the purpose of the max pooling? Tell me.
2 by 2.
Huh? No, 2 by 2. The purpose of the max pooling is to
Matching.
compress the image.
Oh, this is for image compression. I get it. I got you.
Okay, to reduce the size of the image, right? Okay, so why pooling? Look, the actual image was so big. Can you see?
Yes.
After doing the max pooling, the size of the image will be small, but we did not compromise any quality of the image. Can you see it?
Yes.
Kamal, did you understand why pooling?
Yeah, yeah.
Okay. So now Adib, show me your example again.
Yes, sir. Just a second. Right. Yes. Can you see my screen, Professor?
I can see your screen. So Adib, can you please explain now why after the max pooling the size of the image has got small?
So we have less data of the image in the after max pooling, less pixels in the grid.
But why it is happening? Show me the image size and everything, then you will see everything, right?
Yeah.
So show him, show them.
Which one, Professor?
Show them that one. The size of the images.
So
Yeah, you can see the 100 by 100 and 300 by 300. Just go up and show the max pooling. What did I do? The max pooling. Go to the max pooling. Yeah, this one, this line. Can you see? So this the max pooling image is 3 by 3. Can you see 3 by 3?
Yes.
So we are using 3 by 3 max pooling matrix, and it is np.max, meaning if you use np.mean, it will be mean pooling. Mean pooling meaning it will, what is the mean pooling? It will get the average of these 4 values or average of the 9 values. Did you understand?
Yeah.
Yeah.
Okay, so you can use for np.max, you can use the np.mean. If you use the max pooling, it will get the np.max. If you want to do the mean pooling, you have to use the np.mean. But what is the purpose? To reduce the size of the image. Okay.
Yes.
Any question? Now let us go to the CNN site. Adib, can you please stop sharing the screen?
Yeah.
Now I will tell you how the convolutional neural network works. Okay. So, oh, I did not share my screen, right? Okay. Share my screen. Okay. Can you see the screen now?
Yes.
So in convolutional neural network, what will happen? What happens in the convolutional neural network? Everybody understand the convolution, right?
Yes.
Everybody understand the max pooling, right?
Yes.
Now in the convolutional neural network, let us suppose that I have got an image of the cat. I have got an image of a cat. Okay. Okay. So what I'll do, I will use convolution and max pooling on this image. Now you know how to do the convolution and how to do the max pooling, right?
Yeah.
Then I will do another convolution and max pooling. Whatever result we get, max pooling, we do another convolution and max pooling. Okay. You can do many convolution and max pooling together. Okay. Many, not only 1 and 2. You can do many. Okay.
Okay.
Kamal.
Yeah, understand.
Okay.
And I am doing in my.
Yeah. So once we do this part, this is called network, because it is going to be a network. Can you see? Because one after another, it is like a network, isn't it? This process is doing one after another. This process is doing, then this process is doing. This is like a network, right? Layered network, isn't it?
Yes.
Yes.
So we call this network as a convolutional network, CNN. Did you understand?
Yes. It's an acronym.
Yeah. So this is a convolutional network. Now, what is the important thing with this convolutional network? The important thing is that this convolution, we don't know what will be the matrix value. This convolution, we don't know what will be the matrix value. That is why in this network, we need to adjust. We need to change the value of the convolution. Did you understand how we can do it? We will repeat this process again and again by changing the values of the convolution. Okay, we will repeat this process again and again, and at some point we will get very good quality of the result. Okay, if we get very good quality of the result, that is, we can identify, we can say that, okay, this is the exact convolution that we are looking for. Did you understand?
Yes.
Kamal, did you understand?
Yeah.
Okay, once we have got the convolution, the purpose of the convolution neural network is to extract the feature from the images. Like, what is the feature of this cat? The feature of the cat is that the edge of the eye, the edge of the eye, the edge of the nose, and the size of the nose, the edge of the mouth, the edge of the ear, the edge of the head, the edge of the mustache, everything. Did you understand?
Yes.
So every convolution will extract different types of edges. I'll show you a good example. How does it work? Okay, I'll show you. How does it work? Yeah, look at here. This image. Can you see?
Yes.
So we have got the actual image is a car. Actual image is a car, color car. But we will use, this is a convolution, this is another convolution and max pooling, this is another convolution and max pooling. Okay, later I did not discuss about this part. This is a classifier, we will use the classifier technique later. Now every layer we are using convolution and max pooling, and every layer we can see different types of images. Can you see different types of features? This is the
Yes.
feature, this is the features. Okay, every layer we can get different types of features out of this image. Can you see it? Okay, so these features are very important. Our brain uses these features to identify what type of object is this one. Our brain works same thing like this. Okay, so this CNN is working following the activities that happens in our brain. You understand? It is a replication of our brain. Activities of the brain is replicated here. Everybody?
Yes.
Kamal, Badhan and others. Shafil, did you understand?
I'm
Yes,
following.
sir. Yes, sir.
Yes, sir.
Yuan left, right? Yuan left. Jimmy, are you there?
Yes.
Did you understand?
Yes.
Gideon, are you okay with me? Ibrahim Khalil, did you understand? Ibrahim Khalil,
Yes, Professor.
did you understand?
Yeah.
Where is Azim? Bashir bhai, Azim is not joining today class, right? Okay, nice. Now, I think you understood it, right? If you did not understand,
Yeah.
tell me, okay? So now, I think you understood these things. Now I will ask you to follow the code of the convolutional neural network from this website. Just follow this one. I'm just giving you the website. Now follow it. Okay.
Okay.
Adib, follow it. Then I will explain line by line. Okay. I will not run it. Okay. Adib, I'm
Yes,
just
sir.
giving you in the chat this URL of this website. You can open this URL of this website, and then what you can do, copy and paste line by line. You don't have to do anything, just copy and paste.
Okay.
Okay. The purpose of the deep learning is that you have to understand what is happening. Writing down the code is very easy, but what is happening inside it, that is very important. Okay. That I will explain now. I will follow Adib. Adib, you're sharing the screen. Yeah.
So can you see my whole screen, or you're just seeing my
No, I can see your screen.
Okay.
Adib, did you understand?
Yeah.
Something new that I did discuss today, right?
Yeah.
Okay. Now,
so I have to copy this line.
no, just go down. I think there is a whole code of the CNN is there. Go down. Whole code of the CNN is there. You don't have to copy line by line. Go down.
Okay.
Go down.
Here.
This is the whole. No. Okay. Yeah. Copy it. Okay. Copy it. And see whether does it work or not. If it does not work, then we'll go line by line. Okay.
Okay.
In my computer, it was not working. It was taking lot of time. Okay. Let us go. Everybody should copy and paste. It's very easy, right? Copy and paste and run it. Okay. The Google color. In machine learning, data mining, writing down the code is very easy, copy and paste. Problem is that how intelligently you can use it, that is the problem. Okay. Sorry. One thing, in deep learning, it takes long time. Okay. What is the epochs? Can you just go to the epochs? What is the epochs? What is the epochs here? Where is the epochs? Run, test, go up. There is epoch size, go up, score. Yeah, here. Epoch should be here. Yeah. Epoch is 10. Okay. 10. Oh, it is using the K fold. No. Stop it. It will take long time. Stop it. It is using the K fold. It will take hours after hours. Okay. Go to the website. Go to the website again. Now go up. Load the data. Load. You follow it. Okay.
This one.
Go up. Go up. Go up. Go up. Go up. Is it the okay? Yeah, load the data first. Load the data.
This data set, right?
Yeah, load the data. Yeah. Maybe you can stop sharing because we are running out of time. I will not run it. I'll show it. You can follow that website. Okay. While I will not run anything because it's running, this code will take long time. I will show you the code and what is the output of this code. I'll show you line by line. Okay.
Okay.
Look, this is one load the data. If you follow copy and paste, this is the loading the data that you know, nothing new. Okay. Oh, I can. You see the screen?
Yeah.
Yes.
So loading the data. Okay.
Yes, sir.
So once we load the data, then this data is divided into training data and test data. Why
Please
training
share
data
the
and test
screen.
data? I've shared the screen.
Okay, now it's
See,
I can see it.
okay. Once you load the data, you can see the X train and Y train. This is the training data. This is the test data. Notice that X train is the training data input, because we give the input. For example, can you please tell me what is the digit? This is the digit. Is it
9.
9? So I'm giving you the input, and you say me output. What 9, right? So same thing in computer, we give input. Input is the data image, and it will give me the output. What data is it 9, 10, 1 like this? So I give the input. First, I will use this data for training our model, because in the training model meaning what? I want to get the right convolutional matrix for this data. Do you understand?
Yes.
That is the training. Okay. Once I have got the right convolutional matrix for this data, then I will use this data to test. This data I will not use for training purpose. I will test this data to model this model, that whether this okay.
Okay.
So what I'll do, I have divided this data. There are 60,000 data, digit data, handwritten digit data 0 to 9. So how does it look like the digit data? I will show you how does it look like the digit data. It will look like not there. This one. Yeah, the data will look like this. No, this is some other things. Oh, come on. I copied and pasted that thing, right? Yeah. So the data will look like this. This is the data 504192. Like, can you see it? Okay. So data will look like this. What I'll do in this case, I have shown you this data. This is the 9. Okay, and there are 0, 1, 0 to 9 handwritten data is there. So I did the data training and test data. Then what I'll do, and each of the image size is 28 by 28 pixel. Each of the image has got the size of 28 by 28 pixel. Okay, you can see this is 28 by 28 pixel. Each of the image. Okay, that is must. The image size will be the same size. Okay. So and there are 60,000 training data and there are 10,000 test data. 60,000 trained data. Each data has got the 28 by 28 image, and each test data has got the 28 by 28 image, but there are 10,000 data randomly selected. Okay. Everybody. Then once we have got the data is loaded, you can copy and paste from the internet, wherever you can follow any internet. Now I want to use the convolutional neural network. So I have created a convolutional neural model. Convolutional neural network equal to sequential. Why it is sequential? Because if you look at my my PowerPoint slide, it is sequential. Can you see it is sequential, one after another? Sequential meaning one after another. First convolutional, then max pooling, another convolutional, another max pooling. Meaning it is a sequential model. Can you see it?
Yes.
Everybody? That is why I'm using the sequential. Okay. So now let me go code again. This is the sequential model. I'm saying, I'm asking to the computer, hey computer, I want to create a convolutional neural network, and the model will be sequential, meaning one after another. Then I'm adding in the sequential model, I'm adding a convolutional layer. Can you see a convolutional layer? Can you see it?
Yes.
I'm adding a convolutional layer. Then I'm adding a max pooling layer. Can you see?
Yes.
Then I did not add any other thing. Then last layer of the convolution layer will be flattened layer. That I did not discuss. Flattened layer meaning the last layer will be flattened layer. So I have got the matrix. I want to flat this matrix or two-dimensional matrix to one-dimensional vector. Did you understand?
Yes.
Meaning I have got the values 3, 0. Let me show you. I have got the values 3, 0, 3, 1, minus 1, 1, 0, 3. So what I'll do, I'll just make it a one-dimensional data. 3 is coming from here. Okay. 3 from coming from here. I'll show you. 3 from coming from here, this line. 0 is coming from this line. 1 and then 3. Then minus 1, 1, 0, 3. Did you understand?
Yes.
This is called flatten. So in convolutional neural network, the last layer from the image or from the matrix, two-dimensional matrix, we flatten it to make it a one-dimensional data. We call it flattening. So same thing is happening in my code. In my code, the last layer is a flattening layer. It is a layer. Can you see? I'm adding a flattening layer. Okay.
Yes.
After the flattening layer, I will add a dense layer. Dense layer I will discuss in the next class what is a dense layer. But for now, let us consider this a dense layer. Okay. Next class I will discuss what is a dense layer. So this is a dense layer. Okay. Once we have flattened it, I will add the dense layer. The dense layer will give me the classification. What is the digit? Is it a 0? It is 1, it is 2, or it is 3, or 4, 5, 6, 7, 8, 9. Did you understand? The dense layer will classify the data whether it is 0 to which digit it is. Did you understand?
Yes.
So in my code, I'm adding the last layer, I'm adding the dense layer. Can you see dense layer?
Yes.
So I have added the dense layer. Now, if I want to see my model, the model looks like this. You can see first is a convolution layer, then it is a max pooling layer, then it is a flattened layer. I'm using only one convolution, one max layer. Then I'm adding the dense layer. You can add more convolution layer and more max pooling layer. Did you understand?
Yes.
Now, how did I do it? In the convolution layer, I'm asking to the computer that, hey computer, the filter size will be 3 by 3. The filter size will be 3 by 3 and stride. Do you know stride?
Yes.
Stride is 1 by 1. 1 by 1, meaning row 1, column 1. Okay?
Yes.
So
Yes, sir.
padding is valid, meaning it will add extra 0 to the image so that the image size does, after doing the convolution, so that the image size will be fixed. It does not go down, it does not compress. Okay. Did you understand? And the input image will be 28, 28, 1. Okay. I will not discuss about the activation today. I will discuss activation in the next class. Okay. So this is the model CNN. What is happening? I'm giving the computer that the filter size will be 3 by 3. stride will be 1 by 1. Okay, and it will be 25 convolution, meaning it will create a 25 layer of convolution in the same layer. Okay, you can change the 25 to 250. It will be very expensive. You can make it 1. Okay, but here 25, what does it mean? It means that in this example, I'll show you. In this example, I am using only 1 convolution. But if you look at here, there are 3 layers. I'm using 3 convolution. Can you see? 1 convolution, 2 convolution, 3 convolution. Can you see it?
Yes.
So in the same layer, we can create many convolution. In my example, I'm using 25 convolution. Can you see? It is a 26 by 26 input, and it is a 25 convolution. Can you see it?
Yes.
Output shape will be 26 by 26 because it is a stride 1. I'm adding 28 by 28. After doing the convolution, the size of the image will be 26 by 26 by 26. Why? 28 minus 2. That will be 26. It is output shape. Can you see it?
Yes.
And what is the 25? 25 is the layer of convolution, meaning I am using convolution, 25 convolution in the same layer. So it is a 2-dimensional convolution. One is in the same layer, I'm doing the convolution, and then I'm going to the second layer doing another convolution. Did you understand it?
Yes.
Adib, did you understand? Adib?
Yes, Professor.
Okay. So now what is happening? I'm using convolution, 2-dimensional convolution. How many convolution? 25. Each of the convolution. What is the filter size? 3 by 3. What will be the stride 1 by 1? Padding. It will add 0 to the it will not add anything, honestly saying. Then the resultant output of this convolution will be 26 by 26 by 25 because it will create 25 different layers. Did you understand, everybody?
Yes.
Then I will do the max pooling with all of this layer resultant things. And what is the pool size? 1 by 1. This is very rude. It should be 2 by 2. It should be 2 by 2. Okay, 1 by 1. It is not doing anything, to be honest with you. Okay, 1 by 1 maximum. What is it doing? It's not doing anything, right? Let me give you an example. If I put the 1 by 1 max pooling, okay, 1 by 1 max pooling, what will happen? 1 by 1 meaning 1 by 1 matrix. Okay, and I take the maximum. Okay, what is the maximum of 3? It will be 3, right? What will be the maximum of -1? It will be -1, right?
Right.
So it is not doing anything. To be honest with you, it is not doing anything. But if you do the 2 by 2 or by 3 by 3, it will downsize your image. Everybody?
Yeah.
That makes sense.
Yeah, good.
Okay. Then we will do the flatten. Then we will do the dense, and it will give me the result. Now model is ready. Once the model is ready, if I run the model, it will give you the result like this. Okay. What is the result? Let me show you. Did I close down my matrix? Yeah, it will give you the result. Very good result. 98% accuracy. If you run it, the program, it will give you the accuracy 98%. Okay, I'll show you the result. Yeah, you can see the result is close to 97.7%. Can you see?
Yes.
This is the accuracy, 97.7%. Training accuracy. It is the test accuracy. Test data. Notice the test data I did not use for training purpose. Test data 97% accuracy. Training data 99% accuracy. Can you see it?
Yes.
So this is the code. Let me see whether I have got the code with me or not. If I have got the code with me, I'll give you the whole code in one application. I have got lots of code. Let me see, where did I get the code? I have hundreds of code on machine learning. Now let me check what code. Maybe next class I'll give you the code to you. Today I need to find the code. Okay, it's very difficult to find the code. This is the deep learning. Where is the CNN? CNN master. For those who might think that Rafiul, in 3 days you are not teaching anything, okay, or I don't understand anything, I'll show you one of my interview. Bashir bhai, did I show you the interview question in the last? Adib, did I show you? No, right?
No.
Okay, so I'm showing you that I attended an interview for a data scientist position, okay, last year, okay, and I got that job. And imagine how was the salary? Imagine what is the salary of the data scientist? Can you tell me? Any idea what is the typical salary for a data scientist?
120.
Huh?
$120,000.
Come on, it is very less.
400,000.
Who is telling me $400,000? Taka? Dollar or taka?
Dollar.
Dollar, yeah. It is close to the $300,000 to $400,000. Okay. So let me show you the question and the answer. Okay. It is coming. Yeah. So this is the report for yeah, this is for NJ Transit. Okay, it is written here for the data scientist. It's okay. It was 2020. Okay. So this is the problem statement. There are two files. One is the author file, contains information of authors who published scientific papers. The data were collected from PubMed. Another file contains information about investigator who has been successful in attracting funding from the government. Let me show you the file. File is with me. Okay. These are the two files. Can you see the file? It is an Excel file, CSV file. Okay, I'm opening the file. So this is one file. Can you see? It has got the name, last name, and author's name. Can you see?
Yes.
So this is the file name, one file, author's name, another file is investigator's name. So my job was to match the name with this author. Okay, there will be common name in the author file and the investigator file. There will be common name. My job was to match the author file and the investigator's file. Okay, and to identify, summarize these things. Okay, and I have done it. This is the solution. You can see the Python code. Okay, and the result and everything. You can see the result. This is the result. And they gave me 2 hours of time. 2 hours of time. I just evaluated it. And the conclusion is that in this report, we described about the solution of a problem, blah, blah, blah. And we got the, I was able to solve this problem within 1 hour. And he offered me the position. It was an hourly $120. I think $100 or $20. Yeah. If you just, it was close about $250,000 salary.
That's good.
Okay, so this is the example. This is another example, the real world example that this happened. Okay, and what did I do using the Python? Very simple code, pandas. If you look at my code, if you want, I can share with you the code. Harun, yeah, the code is here. Yeah, this is the notebook. This is the code. Look, this is the.
Yes.
So this is the code, and this is the result. This is the result. And you can see I'm using NumPy, pandas. Can you see?
Yes.
That I have discussed in the last class. Do you remember? So don't consider this class course is very, I mean, that nothing. If you can practice this course, believe me, you have got really good demand in the market. Believe me. Okay, and if you know the CNN, machine learning, oh, you're hot cake in this world. Okay. So what I was supposed to show you? I wanted to give you the code tutorial. I forgot. Adib, you have got any code with you for the CNN?
Right now, I have to search for it.
That you can share with others. Because I have to find. I have got hundreds or millions of code with me. Very difficult. Okay. I have used some chatbot, a chatting window or something. That is another thing. Adip, can you please do these things? Okay. So I have already given you the website of the CNN. So it is your homework. You can apply these things, and if you find any difficulties, you can contact with me. Okay. So that is end for today's class. I want to be very respectful to the time. 11:30 is the last time. So those who want to go for sleeping, especially those who are in USA, I'm sorry that I told you that it is going to be 2 hours. So you can do some practice using copy and paste using the, you can copy the URL, and you can go to any internet, any website, internet website, and you can do it. Okay, you can do some practice, because now you understand what is happening, right?
Yes.
Okay, so those who are from New York are here, Jimmy and others. Those who are here, it's late night, you can go to sleep. And those who are from Bangladesh, you can keep staying with me and discuss with me. Okay, those who are in the USA, you can also me if you don't mind, but that is